Assalamualaikum and a very good day everyone. Today I'm going to explain about coordinate systems. There are three main coordinate systems, which is Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system. Okay, now I'm going to explain to you guys what is Cartesian system. Cartesian system. Now I want to draw the line of x, y and z axis. This is y axis, x axis and z axis. Okay. The range of variable for Cartesian coordinate system are: first, for x-axis is from negative infinity to positive infinity. Okay, let me show you this range of variables. Okay, after x-axis is y-axis. It also same from negative infinity to positive infinity, and last one is z-axis. It also from negative infinity to positive infinity. Okay, now let me plot some point here. When we name it as Q, the coordinate A, B and C. Okay, so A, for sure it is for x-axis from origin to A, something like this. And then B for y-axis from origin to point B, and C for z-axis. Sorry, C. Okay. C. Let me make it clear. Point over here. Okay. Okay. Q. Right. Now, the differential of length, surface and volume. We must know there are three differentials. First, this differential length. Okay, differential length. First, A, can put vector dl is equal to dx times 2 vector ax, which is from this one, we can put as A. Next, B is from here, origin to B. B, we can say that vector dl is equal to dy times 2 vector ay. Next is C. C is for z axis, you can say vector dl is equal to dz times 2 vector az, and last one is d is from origin here through the point. You can put it as d. So the equation is vector dl is equal to dx vector ax plus dy times 2 vector ay plus dz times 2 vector az. Next is differential surface. To make it clear, let me draw the surface of the cube. Okay, this is z, y, and x. Okay, surface, we need to know that it is the outer of the box, so you can make it like this. So for this surface, we can say as surface ds x, and this one for ds y, and the upper one ds(z). So the equation for the differential surface first, for dsx, we can say that the dsx is equal to dy times 2 dz times 2 vector ax. For differential surface y is equal to dx times 2 dz times 2 vector ay. Last one, differential surface z is equal to dx times 2 dy times 2 vector az. Next, for differential volume, this is a last part for Cartesian coordinate system. For differential volume, it's only have one, which is dv is equal to dx plus dy, dx times 2 dy and times 2 dz. So this is for differential volume. Okay, that's all for Cartesian system. Okay, now I've done for Cartesian coordinate system. Next coordinate system is cylindrical coordinate system. As we all know, cylinder looks like this. Okay, so to to make it clear, we need to draw the line axis. Z, Y, and X. Okay. Z, we can say as a height of the cylinder or length. So we can plot one point here as a Q, and for x-axis we have to put as rho, y-axis as phi, and z-axis as z. Okay. Rho as a radius from origin to the line here, as a rho. For phi is the angle measured from x-axis to point P in the xy plane. Here, this is a phi. And z, as I told, it as a height of cylinder. Z. Okay. Cylindrical system. So the equation for the vector A, vector A is equal to A rho times 2 vector A rho plus A phi times 2 vector A phi plus A z times 2 vector A z. Range of variable. Range of variable for cylindrical is first, for rho is from 0 to positive infinity, while for phi is from 0 degree to 2 pi, which is 360 degree, and the last one is z, from negative infinity to positive infinity. Okay, next is differential length, surface, volume for cylindrical coordinates. Now I want to explain about differential length. Make it bigger so it looks clear. Then Okay, for differential length, okay, this one is y axis, x and z. A is difference, d length is equal to d rho times 2 vector a rho. A is here, from point here to here is A, which is the radius of cylinder, or the radius of the point to point that we want to calculate. So, and next one is B. B, phi, which is the angle that we want to measure from x axis to point P in the xy plane. This is the angle, and this is the B that we want to calculate, and the equation is dl is equal to rho times 2 d phi and times 2 vector a phi. And last one is C. C is a height of the cylinder, height. So the equation for the differential length is dl is equal to dz times 2 vector az. So this is the explanation for differential length. Next is differential surface. So it just like the Cartesian coordinates, which is we have to plot here, just one, this is small one, 3 sides. The right one to the upper one. Now for this surface, we can call it as ds rho, and this one we can call it as ds phi, and upper one as dsz. So the equation for differential surface, for ds rho is equal to rho times 2 d phi times 2 dx times 2 vector rho. Second one is d phi ds phi is equal to d rho times 2 dx, d rho is times to dz and times to vector a phi. Last one is dsz is equal to rho times 2 d phi times 2 d rho and times 2 vector az. So this is the equation for differential surface. Next is the last one for cylindrical coordinate system, which is differential volume. So same as the Cartesian system, it's only have one equation, which is dv is equal to rho d phi times 2 d rho and times 2 dz. So that's all for the cylindrical coordinate system. Next is spherical coordinate system. For spherical coordinate system, first we need to draw the axis system. X-axis, yes. Okay, y, x, and z. So this point, same as before, we can put it as q. For spherical, the coordinate is r, theta, and phi. Spherical. Okay. R is the radius of sphere. From here, this is R, from origin to the point, and phi is the collatitude measured from z axis to vector r. Angle here. And for phi is the angle from x axis to point P, it's point Q in the xy plane. In the xy plane. Yeah, it's a phi. Okay. Now the range of variable for spherical system. First is r, which is radius, is from 0 to positive infinity. Next is theta, from 0 degree to pi, which is 180 degree. And last one is phi, from 0 degree to 2 pi, which is 360 degree. Okay, for differential length, surface, and volume of spherical coordinate system. First, for differential length, let me draw first. Okay. For differential length, okay, this is y, x, and z. A. Okay. A as a radius here. R, which is R, A. So the equation for the differential length is dl, vector dl is equal to dr times 2 vector ar. Next is B, which is theta. So theta is here, right? It's from 0 degree to pi. So it's theta. So the equation is vector dl is equal to r d theta times 2 vector a theta. Last, for differential length, you can put it as c, which is phi. Here as a c. The equation for differential length for phi is vector dl is equal to r sine theta times 2 d phi and times 2 vector a phi. So this is for differential length. Next is differential surface. For differential surface, here as a dsr and here as a ds phi, and last one here downward as a ds theta. Okay, the equation for the ds vector dsr is r d theta times 2 r sine theta times 2 d phi and times 2 vector ar. So we can read as r square sine theta times 2 d theta times 2 d phi times 2 vector ar. Okay, next is ds vector ds phi is equal to r d theta times 2 dr vector times 2 vector a phi. Last, for the differential surface, is vector ds theta is equal to r sine theta times 2 d phi times 2 dr times 2 vector a theta. So for the surface, as we all know, as you can see that is equal to 4 pi r square. Okay, for the last one, which is differential volume. Okay, for differential volume, okay, the equation for the differential volume is dv is equal to r square sine theta times 2 d phi times 2 d theta times 2 dr. This is equal to 4 over 3 pi r cube. So this is the equation for differential volume for spherical coordinate system. So this is the notes for this chapter that I've made for this video. This is cylindrical system, cartesian system, and last one is spherical system. Hope we can score for this chapter and this subject. Thank you and Assalamualaikum.